Today we discuss the continuity of multivariable function. So first we will see the continuity of two variable function. A function f is a function f which is a real valued function defined on D, which is the subset of R2, and AB belongs to D. This point is in the D. Then the function f is said to be continuous at AB if limit xy tends to AB, f of xy is equal to f of AB. So you know for one variable also limit x tends to f of x is equal to f of a. Same thing here for two variable also. So this is now epsilon delta definition of the continuity. So same thing here, what the limit xy tends to AB, f of xy is AB. That means what, for given epsilon greater than 0 there exists delta greater than 0 such that this distance between this xy and AB, right, this is lies between 0 and infinity. Mod of f of xy minus f of AB is less than epsilon, right? This is the definition of continuity of two variables. Suppose if you want to discuss the continuity of the function in three variables, suppose, so we'll make a change here, three variables. So what we'll do, let f be a function of real valued function defined on, so we'll take this is what R3 then, right, and this ABC, we'll take 3 ABC. The function f is said to be continuous at ABC if limit xyz tends to ABC, f of xyz is equal to f of ABC. Directly you can put the value of x as a, y as b, and z as c. So if you can do this, then that function is continuous. So we'll write epsilon delta definition of the continuity for three variables also. Just you have to add this is what here now. This is plus z minus c bracket square less than delta implies that f of xyz minus f of abc is less than epsilon, right? So this is the continuity of the function three variables. Similarly you can do for four variables and so on. Now note that, so if f of ab or abc is not defined, then f is not continuous, at AB. So if f of AB is not defined, then it is not continuous. Second, if limit xy tends to AB, f of xy does not exist, then f is not continuous, at AB. And third one, if limit xy tends to this is not equal to f of AB, then f is not continuous at AB, is not continuous AB. So remember this. So now you know the algebra of the limits. Suppose f and g are two functions such that they are continuous at AB, then one, f plus or minus g is continuous at AB. Suppose c is some real number, then c into f is continuous at AB when c belongs to R. C is a real number. Third one, so product of the continuous function is continuous. F into g is continuous at AB. Product of two continuous function is continuous. Then fourth one, so f upon g is continuous at AB if g of AB not equal to 0. Denominator should not be 0. Okay? So you are familiar with this one. Now next, with the continuity of the composite function. Continuity of the composite function. You know that f from x to y and g from suppose y to z, g from y to z. Then which composition is exist? So you know that there are f composite. Definition of this is what? G of f of x or f compose g of x is nothing but f of gx. Now here what x, you have applied f on x, so you can apply f only on the domain of the f, right? So x should be domain of the f, x should belong to domain of f. So here x is your x is here in the domain of the f. Now here what, on x you have applied g, so you can apply the function g only on its domain. So domain of the g is what? Now here x is belong to y. Now see which one is exist now, right? So which one is exist? So f of x, so the f of x is the element of y, then you are applying g. Yes, you can apply g on the element of y. Now here what? Then g of x is the element of z. Now you are applying f. F is what here? F you cannot apply on the elements of z, you can apply f only on the elements of x. Now your g of x is not in x, so that means what? This is not defined. So f compose is not defined here. So you are familiar with this. Last year we have seen all the things, right? So now we have to discuss the continuity of that composite function. So let f be a real valued function of two variables. So and g be a real value. G is also a real valued function of one variable. F is a real valued function of two variable and g is a real valued function of one variable. So and that one thing is that what? So g is what? G is a function of g is a real valued function of one variable and it is defined on the range of f. It is defined on this. No, this is very important. Range of f. So that means what? The domain of the g should be the range of f. Okay. If f is continuous at ab, because f is two variable function, it is continuous ab. Now g is one variable function. G is the continuous at f of ab. F of ab is the real number because f is your real number, a real valued function. So f of ab is a real number, right? So g is a continuous on one. G is continuous function of one variable and it is continuous at f of ab. Then the composite function g compose f is also continuous at ab. So that means what? The continuity of the composite function is also continuous. So now one thing is that what? If f of xy is continuous at ab, then one thing is remember that if f of xy is continuous at ab, then f of xb is continuous at x is equal to a and f of ay is continuous at y is equal to b, right? So this is the theoretical part. We have completed the theoretical part. Now we'll see how to check the function is continuous or not. So we'll take the examples. Where is the function? Where is the function? Where is the function? X square minus y square upon x square plus y square is continuous. Is continuous. Now here we have not given the where we have to discuss the continuity, right? So that means what? For this is what the domain of the function is R2 now, right? So at all R2, in the whole R2, you have to discuss the continuity. At each and every point of the R2, you have to discuss the continuity of this function. So solution, let f of xy is equal to x square minus y square upon x square plus y. Now note that numerator is a polynomial function, denominator is also a polynomial function, and we know that a polynomial upon polynomial is nothing but a rational function, right? So that means this is a rational function, and the rational function is continuous everywhere except at the zeros of the denominator. So what is your denominator? X square plus y square is your denominator. Where it is 0? Only at x is equal to 0 and y is equal to 0 it is 0, because this x square and y square both are positive, and the sum of the positive number is 0 if and only both the numbers are 0, right? So f of xy is a rational function, it is continuous everywhere, except at zeros of the denominator. So therefore f is continuous on, we write this on D is equal to set of all xy belong to R3 such that x square plus y square not equal to 0. It is enough. Okay? So x square plus y square not equal to 0. Then you are otherwise the function, if the values of x and y such that x were actually x is not, except that, or you may write this what except that 0 0, or you may write this what r, this is r2, right? You may write this is what r2 minus singleton 0 0, right? Now next, where is the function f of xy is equal to r tan yz is continuous. Now solution, given that f of xy is equal to r tan, so r tan yz is nothing but tan inverse of y upon z. We will write in our language, right? Okay, so let h of xy is y upon z. Let h of xy is y upon z. And g of t is equal to tan inverse of t now. Okay. So now see this. So for tan inverse, you know that tan inverse of t is continuous everywhere, right? So now this is y upon z. This is what? Y upon z. It should be y upon x, I think. Y upon x. This is not y upon z. This is y upon x. Y upon x. Okay? Y upon x. Y upon x. Okay? Now this is what? This h of xy is again the rational function, right? So we know that a rational function is polynomial upon polynomial. We know that a rational function is continuous everywhere except at the zero of the denominator. So here h of xy is continuous on R2 except at x not equal to except at x is equal to 0, right? That is what? That is h of xy is continuous if x not equal to 0, right? Now g of t is continuous on R. Everywhere it is continuous. Right? Now g of xy is also continuous everywhere except at x is equal to 0 now. Right? Now what is this then? This is what? G of, what is your f of xy is same as what? G of h of xy. We will calculate g of h of xy now. What is g of h? H of xy is what? H of xy is x upon y. So g of y upon x now. Now g of t is what? Tan inverse t. So this is what? Tan inverse of y upon x. Right? And we know that the composite function is continuous. Right? If two functions are continuous, then their composite function is also continuous. So that means what here? Now this your h of xy is not continuous at x is equal to 0. Therefore this composite function is also not continuous at x is equal to 0. So f of xy is continuous on R2 except at x is equal to 0. Whatever the y may be now. So that means what here? On x is equal to 0 means on y axis. On y axis it is not continuous. Determine the set of points at which the function is continuous. So we take first problem. Question is same for all. So first one is what? f of xy is equal to xy upon 1 minus e raised to x minus y. X. Right? Now, where the function, now this is numerator and denominator. Take the care of only the zeros of the denominator. Your numerator is well defined for any real number r, for any real values of x and y. So no problem for this one. Now this your denominator is also well defined for any value of this one. But what is the problem? So denominator should not be 0. Right? So write the values of x and y such that your denominator is not equal to 0. That means what? Exclude that point. That point should not be included in your domain then. So what we are doing? We are finding this x and y such that your denominator is 0 and exclude that point. Don't include in your domain. So what? F is continuous on B is equal to xy belong to R2. Just you have to write in one line answer. So when this will be 0, if x is equal to y, e raised to 0 is 1. So if x is equal to y, right? If x is equal to y, then it is 0. So that means what here? X not equal to y. Right? You have to take x not equal to y. If x is not equal to y, then this cannot be 1. This cannot be 1. Right? So that means this. So this will be our go. This is our required set now. Second. F of xy is equal to cos of root of 1 plus x minus y. Now again what here? F is continuous on D is equal to. Now the root is there. So root of whatever the root of this one is a real if the whatever the quantity inside the root must be the positive, must be greater than or equal to 0. For 0, cos is well defined now. So you can take this as greater than or equal to 0. So this is what then xy belongs to R2 such that 1 plus x minus y is greater than 0. Right? So this will be your set so that the function is continuous. Now third one. We take the number of problems so that idea will be clear to you. F of xy is equal to 1 plus x square plus y square upon 1 minus x square minus y square. So if you don't know, if you are not able to write this one, x not equal to y, so you can write this is what here, 1 minus e raised to x y not equal to 0, right? Now here also the same thing here, right? F is continuous on d is equal to xy belongs to r, xy belongs to r. Now what is here? Denominator not equal to 0. Just we write here what? 1 minus x square minus y square not equal to 0. That means what here? X square plus y square not equal to 1. Whenever your x square plus y square is equal to 1, then your denominator is 0. That means what here? X square plus y square not equal to 1. Right? That means you have to delete the boundary of the circle, standard unit circle. Right? So except at, that means what? The function is continuous except at the boundary of the circle. So you have a boundary, that means what? Except at the circle, x square plus y square is equal to 1. That means circle is not in your domain now. Now next example, f of xy is equal to e raised to x plus e raised to y upon e raised to xy minus 1. Right? So that means what here? F is continuous on d is equal to xy belong to R2 such that your denominator not equal to 0. When your denominator is 0, if this value is 1. If this value is 1. When this value is 1, if your xy is 0. That means what here? Xy not equal to 0. For xy it is equal to 0. Then denominator will be 0. So what we are taking? Xy not equal to 0. Right? Next. What are the number? F of xy is equal to ln. Ln means log. Ln means log. X square plus y square minus 4. Now you know that the log of 0 does not exist. Log of negative number does not exist. So that means what here? F is continuous on d is equal to xy belongs to R2. Xy belongs to R2 such that whatever this one should be greater than 0, not greater or equal to 0. Right? Because log of 0 is also not exist. So what? X square plus y square minus 4 is greater than 0. Now then it is well defined everywhere. Okay, so we take the next example. F of xyz is equal to r sine of x square plus y square plus z square. So arc means what? The sine inverse x square plus y square plus z square. Now what is the domain of the sine inverse? You know that the sine function is bounded function, right? And it is always, the value of the sine theta is always lies between -1 and 1, right? -1 and 1 also included. That means what? This must lies between -1. So you have to choose your x, y, z such that the x square plus y square plus z square lies between -1 and 1. So that means what here? Your f is continuous on d is equal to x, y, z belong to R3 such that -1 less than or equal to x square plus y square plus z square 1. Okay? Next. xyz, f of xyz is equal to root of y minus x square ln of z. Ln means log of z. Now see here. Here root is there. That means what? Y minus x square greater than or equal to 0. Here we can write greater than or equal to 0 because root of 0 exists. Root of 0 is 0. Now ln z. That means this is log z. So z must be greater than 0. Not greater than or equal to 0. It is greater than 0 because log 0 does not exist. So if is continued on, d is equal to x, y, z belong to R3 such that what? Y minus x square is greater than or equal to 0 and z is strictly greater than 0. This will be your domain of D then, right? In this domain, your function is continuous everywhere. So I hope that you understand this. So we'll take problem. Discuss the continuity. Discuss the continuity of f of xy at 0, 0. At 0, 0. F of xy is equal to x minus y square upon y square minus twice xy plus twice x, xy not equal to 0 is equal to 0 for xy is equal to 0, 0. Not equal to 0, 0. Okay. Now solution. Given that, just we write this as it is. Given that f of xy is equal to this, right? Now what do we have to do? We have to discuss the continuity at x is equal to xy is equal to 0, 0. So first we will write the definition. We know that, just right. This is very famous phrase in the mathematics. We know that. So even though if you don't know, you can write even that. We know that f is continuous at 0, 0 if, just write definition, if limit xy tends to 0, 0, f of xy is equal to f of 0, 0. If these two sides are same, then your function will be continuous. Now what is our aim then? To find a value of f of 0, 0 and to find a value of limit xy tends to 0, 0 of f of xy. If these two values match, then your function will be continuous. Otherwise, your function will be discontinuous. Now see here, f of 0, 0, f of 0, 0 is given to you, right? This is that, right? So that means you must have to check this limit. Now this limit is exist, and if it is equal to this, then function will continue. If this limit is exist but not equal to f of 0, 0, the function will not be continuous, right? So we'll try for this one and we'll try for this one, right? So we'll check whether these two are equal or not. This is our job now. So first we will find the easiest value. Your easiest value is what? F of 0, 0 is equal to 0. It is directly given to you. Xy is equal to 0, 0. Then your function is 0. Now only we have to find then what? The limit now. So we'll try for the limit now, right? Okay. So let n is equal to limit xy tends to 0, 0 f of xy, right? Xy tends to 0, 0 means xy not equal to 0, 0. Take your function. Your function is this. So limit xy tends to 0, 0 x minus y bracket square upon y square minus twice xy plus twice x. Now we have to check whether this limit is exist or not, right? So we know that limit along two different paths is different, then limit does not exist, right? So what we'll do, we'll try for limit along x-axis, limit along y-axis. Okay, so we'll check the limit along x-axis, right? Okay, along x-axis y is equal to 0, right? So your LB limit x tends to 0. Your LB x tends to 0 now. So what you have to put? So x square upon y is equal to 0. This is what? Twice x. Right? So this is nothing but limit x tends to 0. So this is x by 2 and this is 0. Right? So limit along x axis it is 0. Limit along x axis it is 0. So now what we will do? We will do for limit along y axis now. Limit along y axis. Limit along y axis. So along y axis x is equal to 0. Along x axis y is equal. So L is equal to limit. So x is equal to 0 means y tends to 0. You have to put x is equal to 0. So x is equal to 0 means this is what then y square now. Your numerator will be y square. What about the denominator then? Denominator. Your what? X is equal to 0. This is 0. Right? This is 0. X is 0. This is 0. That means this y square. Right? So this is what? Limit y tends to 0. This is 1 now. And limit of the constant is constant. So this is 1. Right? So therefore we call this as L1 and we call this as L2 now. Okay? So L1 not equal to L2. So L1 not equal to L2. L1 not equal to L2. So therefore what? So L1 limit along two different paths is different. That means limit does not exist. So that means what? Limit xy tends to 0, 0. F of xy does not exist. Does not exist. And we know that. So we have to see that in the note. So if limit does not exist, then the function is not continuous. Right? If f of 0 is not defined, then the function is not continuous. Right? So that therefore what? Therefore f of xy is not continuous. Not continuous at 0, 0. Right? So now this problem is over now. We take another one problem. Discuss the continuity of f. So everywhere now discuss the continuity at 0, 0. F of xy is equal to x square minus y square upon x square plus y square. Xy not equal to 0, 0 is equal to 0. Xy is equal to 0, 0. Okay. Now solution. Given that f of xy is equal to this. Right? What do I have to do? We have to discuss the continuity at 0, 0. Just we write the definition first. We know that f of xy is continuous. Where we have to discuss the continuity? At 0, 0. So we know that f of xy is continuous at 0, 0. Continuous at 0, 0. If this is very important. If limit xy tends to 0, 0, f of xy is equal to f of 0, 0. What is our job now? To find the values of both the sides. You have to find the values of f of 0, 0. You have to find this limit. If limit does not exist, function is not continuous. If f of 0 is not defined, but f of 0 is defined, it is 0. So you must have to check this one. Right? So first we will find f of 0, 0 now. So f of 0, 0 is equal to 0. Now we will find let L is equal to limit xy tends to 0, 0. F of xy. So this is equal to limit xy tends to 0, 0. Xy not equal to xy tends to 0, 0 means they are not equal to 0. Your function is what? X square minus y square upon x square plus y square. So it is better now degree polynomial, both the degree are same. It is better to take the path y is equal to mx. So we choose the path y is equal to mx. So this is equal to limit x tends to 0, y is equal to mx. So this is what x square minus m square x square upon x square plus m square x square. Each term contains x square, it get cancelled. So this is what limit x tends to 0, 1 minus m square upon 1 plus m square, and limit of constant is constant. So this is what 1 minus m square upon 1 plus m square. Now here what the limit depends on m. So therefore limit depends on m, and if limit depends on m, then we know that the limit does not exist. So therefore limit xy tends to 0 0, f of xy does not exist. So limit does not exist means function is not continuous. So therefore f is not continuous at 0 0. Now problem is over. So very simple problem. Okay, so again we take the next problem. Discuss the continuity at 0 0. So discuss the continuity at 0 0 of the following function. We take the function f of xy. F of xy is equal to 3x square y upon x square plus y square. Xy not equal to 0 0 is equal to 0. Xy is equal to 0 0. Now solution. Given that this is your function, right? So what we have to do? We have to discuss the continuity at 0 0. Just again we write our definition. We know that f is continuous at 0 0 if limit xy tends to 0 0. Whatever the point we have to write here, then f of xy is equal to f of 0 0. So now what we will do? The same thing here. We will find the value of f of 0 0. We will find the limit xy tends to 0 0. If they match, function will be continuous. Do not match, function is not continuous. Right? One of them is not exist, function is not continuous. So here what f of 0 0 is directly defined now here. F of 0 0 is equal to 0. So we have this value. So what is our aim? We have to check this limit is 0 or not. Right? So we'll find this limit now. So let L is equal to limit xy tends to 0 0 f of xy. So just we write the value of f of xy now. Xy tends to 0 0. That means xy not equal to 0 0. Your function is what? 3x square y upon x square plus y square. Now see that this is the denominator is your x square plus y square. So you can apply the polar form. So directly we will apply this. What? Limit r tends to 0, x is equal to r cos theta, y is equal to r sin theta. Right? So 3 r square cos square theta into r sin theta upon r square cos square theta plus r square sin square theta. Now your r square get cancelled. So one r will be remain now here. What? So this is equal to limit r tends to 0. Your r square, everywhere r square is there. Right? So r square get cancelled. So this is what is 3r sin theta or 3r cos square theta sin theta. Now cos square theta plus sin square theta is 1. So this is 0. So from polar form, the answer, whatever the answer we get, if this limit depend on theta, then only limit does not exist. If it is exist, then limit will be the exist now. Now here is good thing is that what? Your limit is same as 0 now, right? So therefore limit xy tends to 0 0, f of xy is equal to 0, and this is same as f of 0 0. This is same as f of 0 0. So therefore f is continuous at 0, 0. Very simple problem. Now we take the next problem. Discuss the continuity at 0, 0 of f of xy is equal to xy upon x square plus xy plus y square xy not equal to 0, 0 and is equal to 0 xy not equal to xy is equal to 0, 0. Okay, solution. Given that, we write here now, this is given that f of xy is this. Okay, now what we have to do? We have to discuss the continuity at 0, 0. So we write here, we know that f is continuous at 0, 0 if, we write if here, if limit xy tends to 0, 0 f of xy is equal to f of 0, 0. Okay, so we'll check now these two exist or not, these two are well defined or equal or not, whatever this one. So we'll try for this one, we'll try for both sides. So now here f of 0, 0, what is f of 0, 0 is 0. Now what, we'll find the limit now. Okay, so we'll erase this one, this part is not required for us, we'll erase this now. So let L is equal to this, let L is equal to limit xy is equal to, we'll write the value of f of xy, limit xy tends to 0, 0, f of xy is what, xy upon x square plus xy plus y square. Now see here, degree of the numerator and degree of the denominator is same now. So if degree of the numerator and degree of the denominator is same, so try for y is equal to mx. Try for y is equal to mx now. So we directly write here y is equal to mx now. Limit x tends to 0, y is equal to mx. So this is what, x into mx upon x square plus x into mx plus m square x square. Now see, each term contains x square. That means your 0 by 0 form will be get cancelled, right? So x square get cancelled. So we write here limit x tends to 0. So x square get cancelled. So m upon what we get then 1 plus m square. So now limit of constant is constant. So limit of this one is 1 m upon 1 plus m square, right? So now this is the value of limit. Value of limit is depend on m. Therefore, the limit depends on m. So if limit depends on m, then that limit does not exist. So therefore limit xy tends to 0, 0 f of xy does not exist. Therefore f is not continuous at 0, 0. Is not continuous at 0, 0. We take the next problem. F of xy is equal to x square y square upon x square y square plus x minus y square. X y not equal to 0, 0 and is equal to 0, xy is equal to 0, 0. So what is the problem? Discuss the continuity at 0, 0 of this function. Okay, so solution. Given that, just write whatever the function is as a given that. At least you can write this. Okay, now what we have to do? Discuss the continuity at 0, 0. So when we say that the function is continuous, right, that we know that, right? So we know that f is continuous at 0, 0 if limit xy tends to 0 0, f of xy is equal to f of 0 0. Now once again we'll check this one whether these are same or not. So what is your f of 0 0? F of 0 0 is equal to, this is given, this is 0. Now we have to find this limit now. So we'll say let L is equal to, just we'll erase that because that we don't want this. So let L is equal to this. So we'll write the value of f of xy now. So limit xy tends to 0 0, x square y square upon x square y square plus x minus y square. So what to do for this path? Now if you go see here, if you find the limit along x axis y axis, if your numerator contains the product of x and y, don't go through that limit along x axis and limit along y axis, right? So limit along x axis and limit along y axis will be the same now. So here what is limit along x axis will be 0, limit along y axis also 0. So we'll try to find the other thing now so that we get this one. So we'll try for that also. So at least one limit you have to take in. Limit along x axis and limit along y axis. First we'll take only the limit along x axis. You have the limit along y axis 0. So first we'll find out the limit along that path now. So here now along x axis. Okay, along x axis. Along x axis y is equal to 0. So therefore L1 is equal to limit x tends to 0 now. X tends to 0. Y is equal to 0. So put y is equal to 0. So this will what? 0 upon y square now. 0 upon y square. It is not 0 by 0 form. If it will be 0 by 0 form, then we cannot take the limit along x axis or limit along y axis now here. If both are the 0 0. So now it is not equal to 0. So that means this is 0. That means what? Limit along x axis will be 0. Now we will take the path. So L2 now. Limit x tends to 0 and we'll take the path x is equal to y. We'll choose the path x is equal to y. So put x is equal to y there now. This is what is x to the power 4. X to the power 4 now. Now x is equal to y, then this is 0. 0 square 0. So that means denominator is what your x to the power 4. Now this is equal to limit x tends to 0. X square upon x square is 1 and limit of constant is constant. So this is 1. Right? So your L2 is 1 and your L1 is what? Whatever this. Limit along x axis, limit along y axis, whatever this, it is 0. So limit along x axis is what? 0. And limit along the line x is equal to y. This is 1. So limit along two different paths is different. Therefore L1 is not same as L2. So therefore L1 not equal to L2. Therefore limit xy tends to 0 0. F of xy does not exist. Does not exist. So therefore f is not continuous at 0 0. Okay, again we'll take the problem, discuss the continuity at 0 0 of the function f of xy is equal to of the function f of xy is equal to x cube plus y cube upon x minus y xy not equal to 0 0 and xy is equal to 0 0. Okay, solution given that given that. So what we have to do? Discuss the continuity at 0, 0, right? So first we write this definition. We know that, at least you can write, we know that f is continuous at 0, 0 if f of xy, if limit xy tends to 0, 0, if limit xy tends to 0, 0, f of xy is equal to f of 0, 0. At least you can write this. This is the definition. So that means what? You understand how to check the continuity of the function. Now also you can write this one. At least you get 1 mark now. This is what. So this will be 0. At least you will score 1 mark. And 1 mark is now, this is what? It is very heavy actually. Because what? So we know that in Marathi, thembe thembe tale sache. Alright? So with the help of that 1 mark, you will be pass your exam. So what we do now? We will check now. This is what? Limit. We will find out limit now. So let L is equal to, let L is equal to limit xy tends to 0, 0 f of xy. We will write the value of this is what? Limit xy tends to 0, 0. This is what? Then x cube plus y cube upon x minus y. Okay. So now see here, now there is no product. So we'll check the limit along x-axis and we'll check also limit along y-axis. See what happens. And then we'll choose the other path. If they are the same, then problem will be arise, right? So if they are not same, then our problem will be over. If the limit along x-axis and limit along y-axis is same, then we have to do some work now, right? If they are not same, then our work is over. So L1, limit x tends to 0, y is equal to 0. That means this is limit along x-axis. So x square, x cube, this is x cube. You have to put y is equal to 0 upon x. So this is what? Limit x tends to 0. This is 0. So this is what? X square, this is 0. And if you take the limit along y-axis, that will what? Then y cube upon y, that also 0. So no need to find the limit along y-axis, right? That will be also 0. That means we have to do some work now, right? So because limit along x-axis and limit along y-axis are same. Now here degree of the numerator and degree of denominator are not same. So that means what? You have to do some work. You have to find a path such way that x cube or y cube get cancelled. So for that what we will do? So what we want? We don't want, this is what? Denominator should contain the cubic term, right? And the limit will be, should be the depend on m now. So we'll try for that now. So we'll choose the path. So choose the path. We'll try for this one. Choose the path y is equal to x plus m x cube, suppose f x cube. Okay. So now we'll see what happened there. Now L2 is equal to limit x tends to 0, right? So you have written the path now. So x tends to 0. So this is what? X cube plus y is what? X plus m x cube, right? Upon x minus y. That means minus x cube now, right? So now this what here? X square there. So you can take x common here. So what we get then? Limit x tends to 0, x cube plus x cube, right? This x you can take common. So that means here 1 m x square cube upon. So x is will cancel. See, m x cube, right? So this x cube will get cancelled. That means we are through now. Your value of the limit is depend on m. So if the value of limit depend on m, then that limit does not exist. That means our work is over. Again, if it is 0, then we have to again do some work, right? We have to choose the path so that the limit is not exist. So this is equal to what? Limit x tends to 0. X cube get cancelled now this year. So this is what? 1, right? So this is 1 plus m x square cube upon minus m. Right? Now we'll put x is equal to 0 now. We'll put x is equal to 0. So if you put x is equal to 0, then this will be 0. 1 cube is 1. 1 plus 1 is this. So this is minus 2 by m. Therefore, limit depends on m. If limit depends on m, then limit does not exist. So limit xy tends to 0, 0. F of xy does not exist. Does not exist. So therefore, f is not continuous at 0, 0. Now we take next one. So we have taken the number of problems. So I hope that you understand this. We take f of xy is equal to x square y cube upon twice x square y square, xy not equal to 0, 0 and is equal to 0, xy is equal to 0, 0. Is equal to 0, 0. Okay, solution. Given that, right? What do I have to do? So we know that, okay? So we know that f is continuous at 0, 0 if limit xy tends to 0, 0, f of xy is equal to f of 0, 0. Your f of 0, 0 is 0. Right? So only we have to discuss the limit. Right? We will find only the limit now. So we'll say this is let L is equal to this. Okay? So this is equal to limit xy tends to 0, 0 x square y cube upon twice x square plus y square. Now see here, x square y cube, if you take the limit along x axis, it will be 0. If you take the limit along y axis, that is also 0. That means what? Limit along x axis and limit along y axis is 0. So we need to find other path, right? So we have to do some work now here. So what to do now? So what we'll do? We'll take the value of x square. So choose the path. Choose the path x square is equal to, because here there is x square, now here y cube and y square here, so don't put y is equal to or y square is equal to something, right? So what we'll do, we'll put x square, because x square is here, x square here, direct we can put the value of this one. Now what here, if you put x square, right, we put x square such that this will get cancelled. Now y square or x square get cancelled. So what we'll do for this one, so we'll write this is what, x square. Your y square y should get cancelled. So we'll write this is what, then 1/2 y square now. 1/2 y square. And what you should get then, if you put here the twice x square, then twice y square minus we will write here. Minus. So if you put the what, twice x square, it will be the what, minus y square, then plus y square get cancelled. And we want here then that power should get cancelled. So we write that my to the power 5 now. My to the power 5. Right? So if you put here, see, y cube y to the power 5 will be there. Your denominator will be what? We write here plus now. Plus y to the power 5. Right? So we'll try for this one. Okay? So L is equal to limit x tends to 0. You have put in the value of y, no? So that means you have to take the y is equal to 0, because your this is what in terms of y now. We'll put the value of x square now. So this is what, minus half y square plus y to the power 5 into y cube, okay, upon twice x square. Just multiply by 2. This is what, minus y square plus twice y to the power 5 plus y square. We are trying this. Whether this is work, that I don't know. So if it work, then we are through now. We are trying this. So this is what, then limit y tends to 0, limit y tends to 0. So we'll multiply this y to the power, okay, keep as it is. You can take y square common now. So this is what? Minus half y square common now, plus m y cube, and this is what? Y to the power 5 now. Right? What about the denominator? Your y square get cancelled. Twice m y to the power 5. Yes, we are through. Right? So y to the power 5, y to the power 5, you can cancel this, and your value of the limit will be depend on m then. Right? Y per get cancelled. So this is what? Minus half plus m y cube upon twice m. Now we put y is equal to 0. Then this is what? Minus half upon twice m. So this is minus 1 upon 4m. Yes, we are through. So that means what? The limit depends on m. Limit depends on m. Therefore, limit xy tends to 0, 0, tends to 0, 0, f of xy does not exist, and therefore f is not continuous. F is not continuous at 0, 0. Now the problem is over. We'll take one more problem and we'll stop. So we'll take this problem. F of xy is equal to sine of xy upon x plus y, xy not equal to 0, 0, is equal to 0, xy is equal to 0, 0, xy is equal to 0, 0. Okay, solution. Right, this is given thing. Right, so just to be right now, this is what we have to discuss the continuous 0, 0. We know that f of xy is continuous at 0, 0 if limit xy tends to 0, 0. Right, f of xy is equal to f of 0, 0. F of 0, 0 is 0, 0. Just we'll find now limit now. So let n is equal to limit xy tends to 0, 0, xy tends to 0, sine of xy upon x plus y. Right, we'll take the L1, that is what? Limit along x axis now. Right, so limit x tends to 0, y is equal to 0. So we'll take this. So this is what then? So 0, sine 0, y is equal to 0, sine 0 is 0, 0 upon x, so this is 0. Right, so now what you have to do then? The second part, you cannot choose y is equal to mx now. Right, so for this what you have to do? So we'll choose the path, y is equal to minus sin x. We'll try this, y is equal to minus sin x. See what happened there. So L is equal to, L2 is equal to now limit y is equal to minus sin x. We'll choose this path, and your what? Y is, and your x tends to 0 now. Okay, so sin of x into minus sin x, upon x minus sin x, upon x minus sin x. So this is equal to limit x tends to 0. This is what? Minus, you can take minus common, minus x sin x, because sin minus theta is minus sin theta, upon x minus sin x. So we do, this is what? Limit x tends to 0, minus sin x upon x sin x into x sin x upon x minus sin x. Right, so this will be the minus 1 then. This will be the minus 1, because sin 0 upon 0 is right. So this is what? Limit x tends to 0, So we will apply the L'Hospital rule. Then this will be what? Then x cos x plus sin x upon 1 minus cos x. 1 minus cos x. Again we will apply. This is minus limit x tends to 0. So this is what then? X minus x sin x plus cos x upon minus sin x upon minus sin x. So it do not work. Okay, that we'll try for this. Okay, we'll try for this other thing now. So I think this problem will solve later on now. Now let's take the next problem. F of xy is equal to, we'll take the last one of this. F of xy is equal to sin of x square plus y upon x plus y upon x plus y. Xy not equal to 0 0 and xy is equal to 0 0. Okay, so everything is same. Just we'll try for the limit now. Limit xy tends to 0 0 sin of x square plus y upon x plus y. So which path we have choose now? So we'll choose the path y is equal to mx square. Mx square. So this will what then? X tends to 0. So sin of x square plus mx square upon x plus mx square. X plus mx square. So what we'll do now? This is what? Limit x tends to 0 sin of x square plus mx square upon x square plus mx square into x square plus mx square upon x plus mx square. X plus mx square. So this x you get now. So instead of this, what we'll do? It will be again 0 now. Okay, just we'll write y is equal to mx now. Okay, so this is y is equal to mx now. This will be y is equal to mx. Okay, so now this will what? Y mx now. Okay, this is y is equal to mx now. Okay, this is y is equal to mx now. This is y plus mx now. Okay, so will be thrown now. This limit will be 1 now. This limit is 1 into limit x tends to 0. X tends to 0. Now x and get cancelled there. So x plus m upon 1 plus m upon 1 plus m. Yes, we are through. So m upon 1 plus m. M upon 1 plus m. Right? So the value depends on m. So limit depends on m. So therefore limit xy tends to 0 0, xy tends to 0, f of xy does not exist, therefore f is not continuous, therefore f is not continuous at 0 0. So I hope that you understand this. So problem is that what you have to choose the proper path, right? But how to choose the path? So we don't have the formula. So by trial and error you have to choose the path. So path is depend on the problem. So try to do this one. Try to solve the number of problems and try to understand this. So and try for practice for this one. So I hope that you can solve the number of problems on the continuity. So I will stop here. Okay.